Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, so we have with us today Rod Johnson, who many of you probably know from Spring, creator of Spring Framework, and who has been up here to Crested Butte, actually.
Yeah, we were trying to figure out what the year was. Do you have any recollection? It was one of Martin's.
Hi, Bruce. Look, I'm pretty sure I went twice. I think it was probably 2003 and 2005.
Okay, that could work.
So,
yeah, it was when we were doing the early experiments with Martin Fowler. And
yes, it was Martin who invited me, actually.
Yes, it was like...
that was actually really cool because I think Martin just read my book and reached out and invited me. So
he did, and it's like you go, "Oh, Martin Fowler!" And I was thinking about him today. I'm going, "Yeah, it's like he came along, he waved his magic idea wand, and then he moved on. What a weird superpower to have!" And I'm thinking, no. That's an awesome, to be able to give people good ideas.
Yeah.
That is an awesome superpower. Martin is a superhero.
Yeah, he is.
Yeah.
He's got the idea magic wand.
Yeah,
for sure.
He does.
Yeah. Well, I guess he's just, he's really intellectually curious, I guess. So that's kind of how he operates. Like he goes deep into something and then, moves on to other things.
Yeah.
Yeah.
So, good to have you, Rod. Thanks for joining us. And hopefully you can make it back up to Crested Butte sometime.
I remember when you were here.
I'd like to go in winter sometime, though. I hear you've got nice skiing mountains.
Yep,
I've only been here in summer.
Yeah, we do. The Winter Tech Forum would be the good time to come for skiing. But yeah, I remember you... I tried to understand aspect-oriented programming, and you were explaining it. And I sort of got it a little bit, but I didn't completely get it.
Did Spring exist at that point? Was it?
No, I don't think so.
This was
Rod
was kind of throwing around ideas in his head around aspect-oriented programming and how it could be the foundation for something better in Java land.
Yeah, I feel like it was theoretical.
Is that correct?
The very first time I went, Spring existed, but was like on SourceForge because that was the thing back then. So yeah, there was a reasonable amount of Spring code on SourceForge, but it was only kind of, it was earlier than early adoption. But I imagine I probably went back to wherever I was staying in the evening and did a couple of hours coding on Spring every night.
Yeah.
The second time, I know there were a couple of other people from the Spring team there. There was Mark Pollock and Alex Sevich. I don't know. I think I invited Mark. Somebody else must have invited Alex. So yeah, that was fun.
At that point, it was established. Yeah.
Yeah, but at that point, I had a faction. It wasn't.
A posse.
Yeah.
Well, that was in the summertime. So you haven't been here in the winter then to experience the skiing and all that. So
I have not. Actually, I don't think I've skied in Colorado. It's probably... No, I don't think I have. I've actually skied in a lot of other places. But...
Well, if you like steep and double blacks and all that, then you have to come out here for skiing Crested Butte because it's pretty wild.
It's not only that.
There's a couple green and blue runs.
We do have the largest amount of extreme terrain in the continental U.S.
Yeah.
So
more than Jackson.
Yep.
Yeah. It's pretty wild.
Mm-hmm.
There's many, many places I've never been.
Oh no, and I will never go.
I will never go.
No.
Yeah. Well, so I guess that one of the things I was thinking about asking you was you've been on a journey for programming journey for many years, and I just want to hear a little bit about your journey from Java, Enterprise, Spring, onto Scala, and then TypeScript, and where you are now. So I don't know, give us a lowdown on what your journey through programming has been like, where you've gone and where you are now.
I guess my journey has been an alternation between exploration phases that were kind of driven by curiosity and kind of implementation phases, which were driven by building something, building a company, building a product. So I've always gone through those switches, and I really like both of those things. Like, I mean, it is very, very satisfying to see a product come together, and especially to create a team as well as a product, and see that it's something that goes on really strongly and becomes a lot bigger than you as an individual. So I find that satisfying. But there is no pleasure in life quite the same as learning a new technology or learning a new programming language, because that kind of enlarges your brain or activates parts of your brain that you previously didn't use enough. So that is also deeply satisfying.
Yeah. Well, it seems like that's something that, I don't know, not enough people in programming do. Maybe that's a judgment against people, but I was talking on Twitter with some people, and they were like, Rust was saying how it would be impossible to do to have like syntax without semicolons. This is in the great semicolon debate of this week on Twitter, which was very fun. But somebody pointed to, it was Kit from the Zio team, pointed to how Rust had decided not to do no semicolons, and Kit was posting snippets of the conversation in the Rust community about how it would just be impossible for a programming language to not have semicolons, and with all these different constraints. And they were very clearly unaware of Scala. Like the Scala had already solved all those problems, and it's like, gosh, like I would love for more developers to experience more programming languages and get that brain enlargement.
So they would even know that it was possible to not have semicolons.
Yeah, exactly.
Yeah, that's
just for that one alone would be sufficient.
Yeah, well, see,
I have to say on that, it's not without a cost, but
that's right. The Scala compiler is slower, I'm sure, because of it.
I think, look, to be honest, I think I went too long with the C++ then Java stream. Like, I mean, that. Well, obviously wrote a few books, created Spring, then Spring Source. So that implementation phase was like a 10 plus year
long
implementation
cycle,
phase.
yeah.
And during that time, I really didn't look at other languages except for competitive analysis. So, for example, I remember looking at Rails. I had zero interest in Ruby as a language. I still have zero interest in Ruby as a language. All my interest was, okay, this is a competitive web thing. What can we learn from it? And ultimately, we learned a lot of things from Rails, more from Rails than for Ruby. It just wasn't an option for me to put in the time to, look at other things deeply, apart from obviously Aspect J. Whereas once I had moved on from that, I did start looking around, and that's what brought me to Scala.
Yeah, so you were doing quite a bit with Scala for a while, and we're on the board of TypeSafe, now Lightbend. Are you still on the board for?
No, I am not. Though
okay.
I'm an investor in the company, so I still have an interest. Actually, I quite coincidentally had an email exchange with Jonas the other night.
Oh, good, so,
nice.
Yeah. So that was overlapped with the time that I was at TypeSafe, and was really fun to get your perspective on Scala, coming from so many years in the enterprise Java world, and kind of seeing how you saw Scala and its potential and things that it could be. And one of the things, maybe that part of the journey that would be interesting to hear about, is you and I worked together for the Scala Days 2015. Did you say it was
2013?
2013. Yeah. And you did the keynote on the gist of it was about how Scala could become a mainstream language, and that was kind of at an inflection point of like Scala can kind of choose which direction it wants to go. And I don't know, tell us about your recollection of that presentation from almost 10 years ago.
It was highly entertaining. Remember, it was in a beautiful off-Broadway theater, which I guess was cool. Sheila and Mark Brewer had this knack for finding amazing places. So it was quite a beautiful environment. I don't think I've ever spoken in an environment quite like that. A bit more stylish than we generally get in tech. And I remember the reaction to the talk was possibly the most polarizing talk I've ever seen. Like, if I remember correctly, probably 2/3, 3/4 of the audience gave it a standing ovation, while the remainder was sitting scowling and not clapping at all. So it clearly
Yep.
And essentially, the gist of it was that Scala is pretty great. There are things that are really problematic about Scala, like binary compatibility, the fact that every single release of Scala breaks a ton of things. Hey, no, you guys don't like Java a whole lot, but just hold your nose a little bit while I tell you the reasons Java is as popular as it is. And maybe we should learn. We don't need to become Java, but maybe we should reflect on those things. There are reasons why Java is so popular. And actually, didn't I start? I started that talk by copying the old idea of Perl poetry.
That's right. I remember the poetry.
Everybody knew about Perl poetry. I guess back when I was, maybe it was slightly after uni, but like one of my uni buddies used to write Perl poetry. I thought everybody knew that you can write, you can and do write poetry in Perl as a thing. But apparently it got a bigger impact because not that many people knew that. So I wrote a poem in Scala. Obviously, there did need to be, because Scala is strongly typed, there did need to be some code behind the poem. But like what I showed did compile, a part of it compiled, and it looked exactly like a poem. And my point was, languages you can write poetry in have pros and cons. So essentially, I was arguing that Scala needed to make some more pragmatic choices to become a mainstream language. And I predicted that the title of the talk, I think, was Scala 2018. And the argument was that, the moment of truth will be 2018. Scala will be either the next mainstream language or it will have just gone back into its niche. And here are some of the things you need to think about.
Yeah.
Looking back on it, I think, to be honest, I was on the money. And, I think I am not sure whether I mentioned it, but I was certainly thinking that something like Kotlin would come up that would do enough of the things that people want done, that the extra bells and whistles of Scala would, really not present that amazing a trade-off.
Yeah. Yeah.
I mean, there are still things in Scala. I haven't written Scala probably for 5 years now. And there are still things I miss every day, like the fact that every compound statement is an expression. Yeah. It's like other C family languages. That's like the semicolons, right?
Yeah.
It's like, obviously, Martin or somebody asked the question, what if every statement was an expression? What if it doesn't matter if it's in curlies? What if it returns something?
Yeah.
And
once you experience it, you have a hard time going back.
You go, right? Why aren't they all like that? That's the real question. It's like, who thought it was a good idea to not do that?
It's just that maybe no one had ever seen that possibility before.
Yeah, I don't know. But
like with semicolons, it's like until you see the potential of not having semicolons, you don't realize how nice a world without semicolons is.
Yeah, but this is even more fundamental because it's like, everything generates a result. Why do we have to treat it differently in one case? It's almost like the red and blue, or the different colored functions for async and await. When you really start digging into it, you go, oh wait, we don't really need to do this, do we?
Oh well, I mean, I think it just makes things so elegant. Like, it really annoys me now when I have to use a mutable variable, because I can't do that. Like, for example, I want a switch statement to return a value. That's probably the single biggest thing I miss. But I mean, Scala is a really beautiful language in many ways. It's just that if you're going to have a large team building something, it is absolutely certain that you will have somebody who came from a Haskell background who will write Scala that will explode the brains of anyone who looks at it. That person will not only do it, they will take pride in doing it, and the only way you'll stop them doing it is by firing them. And then they'll probably blog about your company. There are practical problems that occur with a language like that. Whereas a language, if you have to do something that requires a fairly large team, a language like Java is really pretty safe. I personally, I will never be one of these people who hate Java. I think it's a very important and very beneficial language. I personally don't choose to write Java at the moment, But I think there is a very, very important need for a language like that actually doesn't try to do too much and doesn't try to be too clever.
Yeah, it's like team structure and team size are an important factor in programming language, how good a programming language is for you. And in a if you're in a team with thousands of developers, I think what you're saying about Scala and the multitude of ways that people can write Scala has some real downsides, whereas Java and the constraints of the language work better at that scale. I don't know.
Yeah, Scala has a number of, I don't know, are they experimental features? Are they just in dark corners or whatever that I don't, you know, and somebody could come along and decide, oh, we're going to use this feature, and now everybody else on the team has to understand it in order to be able to read the code. It's like, I love that Scala experiments with things, but I totally see if you had a team of more than a few people who aren't all Scala wonks, it's going to be a problem.
Yeah.
It also, this brings me to a really interesting point I've always thought about languages, which is that although we've been talking about how learning a new language can grow parts of your brain, I believe people over-index on languages. A language is just one part of the story. So, for example, in the Scala community, one of the things that they did is they refused to use any Java library. So, for example, well, Spring's a framework. It's not even just a library, but not just Spring, like anything else that was mainstream Java. Guess what? They're in a language where they could consume that. They could even put a trivial little Scala wrapper on it that would make it look beautiful. But no. No, can't possibly use that.
Got to do it from scratch.
In Scala from the ground up.
Make it Scala idiomatic.
Which meant that we ended with a bunch of libraries that were buggy. Take, for example, transaction management.
Yeah.
Spring transaction management is something that's been hardened by very smart people with access to, people within the teams in the application servers when that was still a thing, all that kind of stuff for 15 years. It's been used by probably millions of people. It is pretty much as stable as you can possibly get, a piece of framework code. You go and write your Scala transaction library, you're going to go through the same amount of learning. The difference is you're going to go through it 10 times slower because you don't have anything like the same community behind you. So I think that, and I'm sure that was one of the things in my talk, I think that really held Scala back. It's interesting, the Clojure community, as far as I understand, have not done that. And they're happier to use Java libraries that they can consume. And I think that's a really sensible choice. So if you're solving a whole lot of real world problems, language is, I think, often a second order issue. For me, that comes out when I'm doing anything involving ML. And I've played around a bit with neural networks and TensorFlow in the last couple of years for my own amusement. I do that in Python.
Yeah.
I do not like programming in Python personally. Python is a language that I think is a really good language and has a really valuable niche. So this is not me saying I think Python's a bad language. It's saying I personally find that Python is not a language that was created for people like me. But you know what? If I'm doing something with training a neural network, I'd be dumb to do it in another language, because in Python, any answer I want to anything, I can Google in 30 seconds. Whereas if I go and do it in a different language that I might prefer, I'm creating a whole world of pain. And honestly, what for? I mean, I have like probably maybe 1,000 lines of Python in most of my machine learning projects. So, I mean, compared to what's happening with TensorFlow and all the ML stuff, it's kind of a pretty trivial thing. And to me, that it is a mature aspect of programming to be able to hold your nose and say, maybe I don't love this language or I don't love this tool, but it is the practical way to solve this problem.
We tend to get pretty attached to our programming languages and communities and have a hard time admitting that maybe we should use a different language for a given problem set. And I think there's the ethos of it where Scala community, I feel like a lot of the mentality of it that's kind of unspoken is, oh, we can do that better.
Yeah.
And I think that that's why they didn't use the Java libraries, is because it's a lot of really smart people who really do believe and probably can do it better. It's just that the amount of time it takes to iterate through the real world challenges and optimizations.
I didn't realize that. I mean, what you said about Scala, I didn't realize that somebody in the Scala world had said, no, we're not going to use these pre-existing tested libraries. Because, I mean, you were talking about Python. That's what brings a lot of people to Python. It's like, I have a problem to solve. Oh, there's this library that might solve it. Oh, I wonder if I do this. Oh, my problem is solved now. You get that kind of, I don't have to write the code experience. And so to actually turn away from this body of tried and tested code is an interesting choice.
Yeah.
Yeah. Yeah, I don't think it was any single person who consciously set that out as an agenda. It just kind of grew out of the community. And I think it was very, very unfortunate. Because again, I think people who get really into languages confuse language smarts with general smarts. So, just because, for example, you might be more fluent in truly advanced, obscure mathematical language constructs or choose to use them does not mean that you actually have a better understanding of a particular tech domain than, say, a Java programmer who's worked on it for years. I mean, it may well be that that person is equally smart, but they decided to spend their intellectual effort on things other than language syntax constructs.
Yeah. Domain problems.
Mm-hmm. Which ultimately is what gets you to business value.
Yeah, that's right. Yeah, I think the Scala community is interesting that way. I see them solving a lot of problems that are not directly tied to business value or trying to accomplish
but they have moved the whole programming world forward by the experiments that they've done.
Yeah.
So it's I think it's a good trade-off that we got. Yeah, maybe Scala isn't the dominant language at this point, but the things that we've learned from the Scala experiments have been
very
really
beneficial for everyone.
Super valuable for everybody. They've influenced all these other languages.
Yeah, and I mean, you can write beautiful code in Scala. Yeah.
All of my Scala code is beautiful. Yeah. Yeah, so you went through the Scala phase, and we got to do some of that together, and that was a lot of fun. Then where did you go after Scala?
So after Scala, we started to do more, I guess, on the client side, which got me interested in TypeScript.
Yeah,
and I'm a huge fan of TypeScript. Yeah. I think it is truly impressive what they've done, taking the JavaScript language and ecosystem and gradually erecting a pretty damn nice type edifice on top of it.
Yeah.
I found, to my great surprise, that I enjoyed programming in TypeScript probably more than I enjoyed programming in Scala. And it just felt that little bit more pragmatic. The type system is actually very good. The TypeScript system is surprisingly good. I mean, of course, there is some beautiful stuff like everything being an expression in Scala that you don't have. But the type system, like algebraic types, there's a whole range of things that you can do in TypeScript that are really pretty nice.
Yeah.
So I've been predominantly coding in TypeScript probably for the last 4 years or so. And again, it started out with that practical choice. Like, where is this code going to run? Okay, it has to be written in some form of JavaScript.
Yeah.
And
targeting a JavaScript runtime.
I like strong types. Yes, I like strong types. So let's have a look at TypeScript.
Yeah.
I actually think that the notion of adding typing to a dynamic language works really, really well. I mean, it's kind of interesting. I don't think it's anything we've had before unless...
Well, we experienced it with Flex. Yeah. Actually, it sort of went the other way. What you could turn it off, right? It It had
optional dynamic typing.
Yeah, so you could turn this. If your code was starting to get too messy because of the static typing, you could temporarily turn off the static typing and write what you wanted.
Yeah.
And then, of course, Python's added optional static typing, and I'm totally addicted to it at this point.
Yeah,
I
doing it
love
where you want it.
Python type-ins. I use them exclusively. Yeah, I guess that's it really annoys me when I have to read code in a library that hasn't done that, because
which is most code.
Yeah, gradual typing, I think, is one of the
gradual
descriptors.
typing, I think, is the term I'm looking for, and I think that works really, really well.
Yeah,
John DeGoes has this kind of knock against gradual typing that he said something like, gradual typing so that you can find out about your errors gradually in like a snarky way. And I was like, yeah, I feel very snarky about that, but pragmatically, like, there is a lot of people who have a much better experience finding out about their errors gradually than trying to get everything to satisfy a compiler when you may not actually understand what types you need to define yet.
Yeah, and there are also some things where the compiler isn't quite smart enough yet. Like, one thing that bugs me is the ternary operator. Yeah. Because we don't have everything being an expression, I have to use the ternary operator. I never used it in Scala. But with the ternary operator, like, obviously if you do if condition, the TypeScript compiler is smart enough to know that, for example, if this thing was defined, that you can access it within that block. Whereas if you use that
like the
kind of thing in a ternary expression, it doesn't work. And
so like there's like in TypeScript the what I would call in Kotlin, or what they call smart casting, where it knows that you've checked that it's this type and now you can reference it as that type without having to do a cast. So TypeScript does that, but then it doesn't do it in a ternary expression, only in
yes.
a if.
So that really does annoy me, because I end up having to either use tsignore or do a as any, which is like ugly. But by and large, I think the compiler is really pretty smart. I mean, I don't know what the equivalent is in TypeScript, but like the writing a little function to say that A is foo. That works really, really nicely. So yeah.
In TypeScript, and I've only done a little bit of TypeScript, so I don't have a very good understanding of a lot of the language parts of it. But does TypeScript have the ability to do, let's say you're doing a if else, and you have two different types that are returned between the true and the false? Does TypeScript turn that into an ADT, some type of those two types?
So TypeScript will know if there is a binary choice. TypeScript will know in the else that this is the other thing.
Yeah. So I think
does it
Scala
do
3 does that now
too, of intersection of the two types?
Yeah.
I don't know. I haven't tried that. I'm not sure.
So one of the things that, as we've been exploring Scala 3, that was really amazing was that you probably experienced this in Scala 2, where it would go up the type hierarchy and find the most common parent across the two different types. Whenever you have something that can return two different types, it'll just go up to the common parent. Whereas now in Scala 3, it doesn't go up the hierarchy. It assembles a new sum type that is the foo or the bar of those, and so now you get a new anonymous type for those. And the developer ergonomics of that, like automatic sum typing, is pretty amazing.
Wow, that's really cool.
And maybe TypeScript does it, and I'll have to look into
Python
that.
does it.
Python does it. The automatic sum typing. Yeah, cool. It just makes so much sense when you have a language with sum type support to do that automatic sum typing. Yeah. So okay, so you've done some TypeScript and enjoyed it for the most part. A few little places where it didn't give you the power that Scala gave you, but you then built Atomist in large part on TypeScript. Is that accurate?
So Atomist, the languages involved on the server side are predominantly Clojure, running on the JVM.
Oh, interesting.
And on the client side, because we kind of had a thick client that would connect to the server, was Node and TypeScript.
Yeah.
So yeah, I mean the part of Atomist that's actually ended up being most strategic is written in Clojure.
Okay.
So that's now, the thing that Docker are vigorously moving forward is actually virtually all written in Clojure.
Nice. Huh. That's cool. So then on the TypeScript side, a lot of the plugins that people were building for Atomist, those were predominantly coded in TypeScript. Is that right? Like a
They were
lot
pretty
of
much
your kind
all TypeScript. I mean, there might have been some JavaScript, but predominantly TypeScript. And I mean, I think for any library at this point in the JavaScript ecosystem, I mean, having types, ideally the thing should be written in TypeScript, but it really does need to provide types. It really annoys me when I find something that doesn't have types. And it
yeah,
does seem to be the way things are moving.
yeah, yeah. It seems like a big part of that ecosystem is moving to TypeScript for very good reason.
Did you look at, or have you looked at WebAssembly much?
I have not. I have a bunch of friends who keep telling me
Nudging you.
I need to look at it, but maybe that's the next area where I expand my brain.
Yeah.
Have you looked at it?
Just, trying to keep up a little bit and understand what's going on. That's primarily it. I haven't written anything in anything that generates WebAssembly,
Mm.
but it's kind of fascinating, especially the idea that it could one day displace JavaScript.
Java,
Yes, yes.
JVM,
No,
and
no
JavaScript.
JavaScript,
Yeah,
WebAssembly.
all
Yeah,
the things.
yeah,
Well,
That's
JavaScript first, maybe.
yeah.
yeah.
So yeah, I
There's
have
been
been doing a
there's been a
lot
lot more
more
energy
stuff.
actually to displace the JVM.
Is that right?
Yeah,
Yeah,
With
I agree.
WebAssembly,
yeah.
okay.
Yeah,
As
yeah.
being like this portable runtime for
Boy, if we
applications.
get a new virtual machine, I'd sure like it to have better support for immutability.
Yeah. Well,
Yeah, I mean, I can see the potential. I have been doing more stuff in the browser lately. I've always avoided UI programming like the plague because it always made me feel dirty.
yeah.
Like every few years, I dip my toe back in the water and write something and always think, ugh, that's really
Yeah.
horrible code, and I'm not
That's how
even sure
I've
it's my fault.
usually felt too.
And most recently, I've been doing stuff in React, obviously
Yeah.
in TypeScript. It doesn't feel
How's that
like horrible
experience?
code. I'm actually quite impressed. I think we
Huh.
may have finally gotten to the point where we're starting to get libraries like React or frameworks that really enable you to write testable, nice UI code. Feels very different.
Hmm.
I feel like I was reading something recently about React, how they they did something to kind of screw up the whole component model of React in newer versions or something, but I don't know the details
Well,
of
they
it.
changed from classes to functions,
Okay.
Hmm.
No more
which
inheritance.
was a pretty massive change. I think they were probably right, but I suspect it may have made the learning curve tougher. And now both models exist, so that's kind
We're
of
in this
not ideal. I'm
transitionary
using
period.
purely the function model, but yeah, I can see if you're familiar with it, the notion of the component as a class like makes obvious sense for people who know object-oriented programming.
Yeah.
Whereas the way in which the functions work with other hook functions, the side effect and the like, it's actually very powerful, but it is conceptually more complex, I think.
Yeah.
I was fortunate I got into it after they'd made the change, so I learned the new way.
Ah, okay. Cool.
Hmm.
Yeah. Yeah. I guess coming into it from the more function oriented way. And then you're familiar with the ideas of like composition over inheritance. So probably that there wasn't a learning curve for you
No,
on that
no,
respect. So,
no.
yeah.
Do you spend much time on Spring anymore?
No, I do not. Like every so often, I check out what's new. But no, I haven't. Haven't probably written a Spring app for a few years now. I actually seriously would. There are a lot of apps that I would, or services I would build using Spring Boot.
Yeah,
I think it's a great experience.
it is.
So yeah, I think they're doing a nice job.
Yeah, they have.
It just so happens that none of what I'm doing at the moment is naturally suited to the JVM or Java. So basically, these days it's TypeScript or Python.
Yeah. So are you still working on Atomist? Is it still your
I'm still a advisor at Docker. Yes, so I'm not
okay?
working on code, but I'm kind of helping with strategy and
So Docker acquired Atomist. Is that
yes,
just
Docker
recently?
acquired Atomist in June.
Okay, congratulations. That's
So
exciting.
thank you. So yeah, I think you can expect to see obviously the security features from Atomist being integrated with Docker Hub. But I think you can also expect to see some of the Atomist automation features gradually appear through Docker. So yeah, I mean the team's really happy. I think it's a really
Seems
nice
like there's
fit.
a good synchronicity there and good
Yeah.
pairing of technologies. Yeah. Um, maybe step back a little bit and tell us a little bit about Atomist and what it is and what it does, and talk about that for a few minutes.
So Atomist, I mean, I guess fundamentally made the mistake of trying to do too much. But essentially, what Atomist is an event-based system centered on a database that observes everything that happens through your delivery process. So there's a database that's correlating things. So you make a commit, it can correlate that to, say, building a container, various security checks that might occur on that, to deploying to a Kubernetes pod. So it's constantly, when it ingests in events, it's looking at this database and correlating that event with what it knows about, for example, this commit chart, which is usually the fundamental correlation element. And that turns out to be pretty powerful because it enables you, firstly, to have a system of record of what happened from developers commit to production, but it also gives you the ability to see how things are changing over time, to
Yeah.
see and respond potentially to deltas over time. So essentially, we pivoted to security use cases around that because obviously one of the most natural immediate values you can get from knowing the state of the world and the impact of changes of the world is answering certain security questions about increases in vulnerabilities.
Yeah.
And that was the core of our business when we sold. But I think that Docker totally gets that this database is something that's quite generalized and I think actually unique. And so I think they see that as an interesting part of their world moving forward.
Yeah. Yeah, and I remember years ago when you and I were talking about Atomist, and you were explaining it to me. The thing that resonated for me around it was that it's kind of bringing the tooling that Google has around Google 3, the mono repo at Google,
Mm.
to a microservice, multi repo world, and the ability to take a whole bunch of repos and apply consistent policies and checking and have those defined externally to all of the different repos. So kind of bringing a lot of the mono repo benefits, but to a multi repo world, and it's something that everyone that's not Google needs, I think. Everyone except for Google has multiple repos and no way to manage policies and observability around the pipelines from commit to deployment in the way that Atomist is doing. So I was very fascinated by the problem space that it was in.
The way that you described it reminded me of what Kafka does with the events. Is there
like a ledger, the ledger piece
Yeah,
of
the
it.
ledger. Yeah, we'll just keep track of all the events.
Yeah.
Yeah, having
Well,
like the
actually, in
auditability.
the core of Adamus, technically, today is datomic.
Yeah,
So yeah, I
which
mean,
is
it's
an
essentially sort of
immutable
it's a log. Yeah.
ledger,
Yeah.
Hmm.
Yeah.
and that's why you use Clojure. So
Yeah.
that makes
Well,
sense.
actually, do you know Jim Clark,
Yeah,
the chief architect at Atomist?
yeah,
Jim is pretty big Clojure fan,
yeah,
but yeah, given that the best fit for the database was definitely Datomic for what we needed, and that actually enabled us to solve some really interesting problems of changes over time.
yeah,
Prior to that, we'd successfully achieved the relationships and we had a very strong solution for that. But we imposed a lot of work on the author of, an automation to track changes over time. They'd have to go
yeah,
and query. Whereas what we've been able to do with Datomic is not only keep the state at any point in time, but effectively respond to those changes. So at that point, writing the code in Clojure was a very natural
yeah.
thing.
Well, it sounds like maybe you took some of your experience from the world of Akka and event sourcing and CQRS and applied those architectural principles in some way to what you're doing at Atomist. Is that at all
Oh,
accurate?
definitely. I mean, like Jim architected that part of the system, but I know Jim actually did Scala for a while. Jim,
Yeah.
I believe, tried at one point to evangelize Scala within Oracle, and I don't think he had great success there.
No, I
Yeah,
cannot imagine.
That would be a
yeah.
steep uphill path.
Oh, yeah, I think there's a hard no
Yeah.
for that one.
Yeah,
Yeah.
well,
So with the
actually, apparently, I heard that Oracle these days is insistent that everything is in Java.
Yes.
So apparently, if Oracle acquire companies, they will rewrite the stuff in Java, which seems pretty
Seems a
crazy.
bit extreme, but
yeah. Well, they're committed.
absolutely they are. They bought Java and they're gonna run with it.
Yeah. Uh, so it's cool to hear that Atomist stuff is going well, and with all the open source supply chain stuff that's happening, it seems like it's a good time for Atomist to continue to grow at Docker. So that's cool.
Does even open source have supply chain problems?
Oh yeah,
Oh
especially in
yeah,
the
How?
massive supply
yeah.
chain problems.
It's all malicious.
Okay.
Yeah.
It's
Well,
people.
with the supply chain, I mean, the beauty of the kind of database we have is when something like the log4shell exploit occurs, you can ask the question instantly of where is this package across a customer's estate. So, I think that because the world is we've always got an up-to-date model of the world, it means you don't have to wait for scans. You can say, okay, we know exactly where this thing is.
Yeah, yeah. It's that bringing the mono repo functionality to the multi repo world. So
Yeah.
yeah, it's being able to query the database and say, across all of my many repos, where is this dependency being used? And yeah, that's cool. Well, and by using Atomist, I'm sure that there's the ability to assemble the like bomb, the or what do
Yes.
they call it, S
Yes.
bomb or whatever,
Yeah.
from the dependencies as an Atomist plugin or something. So yeah, good timing for Atomist, and it's still going, right? So if people are
Yeah,
interested
yeah,
in that,
yeah,
they can still
and yeah, I
check it
think
out.
I think watch the space with Docker. I think it'd be interesting to see as these
Yeah,
features start to surface.
yeah. Cool. So you're still doing some of that stuff, and then you'd also mentioned that you're doing some chess stuff. So I want to hear about what your
Yeah, well,
explorations
like
of chess
everybody
are
else,
there.
I watched Queen's Gambit.
Yeah,
Did you guys watch? Yeah,
yeah,
it
yeah.
was
That's
it. It
fantastic.
kind of brought me back to. I was probably about 2 or 3 years. I was pretty serious about junior chess. Played in the Australian Junior Championship when I was 16. And I hadn't played chess for 30 years. But I started to get back into chess, and then I started to get interested in the state of chess software. One of the things that I did, actually, I think it was my third summer holidays after third year computer science. I wrote a chess engine in C++.
Nice.
And so I'd always had a bit of curiosity about that space. But what I'm really most interested in is not so much engines. That's a solved problem. I mean, the engine, Magnus Carlsen, the world champion, has as much chance of beating the best engine as I have of beating him. Which is he has as much, about the same chance of getting a draw with the best engine as I have of getting a draw with him. And both of those things are exceptionally unlikely. So the engines really are a solved problem. I mean, the way we got here is actually totally fascinating. But what I'm really interested in is trying to bring AI and software to revolutionize how people learn chess.
Cool.
Like engines can now play chess at a essentially godlike level, but most of it's neural network based now, so
they're not telling you why they're making the decision they're making.
No, they can't.
They don't even know why.
Whereas with chess training, I think we haven't seen quite the same degree of transformation. So I've been playing around with experimentation on this. I don't know whether it's potentially a business, whether it's open source, whether it's just something that entertains me a few hours a day running code in TypeScript or Python, but we'll see.
Yeah.
That sounds really interesting to me, because when I think I was like 8 or something, somebody gave me a chess set for my birthday, and I started learning the game. And then my father had never played chess, and I started teaching him how to play the game. And while I was teaching him, he beat me, and that just like I've never wanted to play chess since then. It just seems pointless, because whoever I teach is just gonna, well, like you, I kind of nursed you into mountain biking, and now I can't keep up with you. So it's like this keeps happening to me. So I'm just going, I'm out. Whereas your game would be kind of like like when spell checking came along, and you go, oh yeah, I guess it kind of just gently taught you to be a better speller. And if I had an experience like what you're talking about, I'm going, okay, don't just flatten me every time I play and train. GNU chess does that. It doesn't matter where you set it. It's just like, bam, you're dead. And it's like, if it would just kind of guide me into it, that could be a whole different experience.
Yeah, I started off was writing something that was based on a database. So I ingested 2 million Grandmaster games and shoved them in a Postgres database. And essentially, the interface enabled you to explore opening theory in games. So you could go and drill into an opening variation, look at all the Grandmaster games. And it was actually quite nice, but I mean, in terms of potential business use, it's very much a niche market because it's built around people who care about opening theory. So, when you look at, say, people who play online, probably the top 10%, maybe the top 25% care to some degree about opening theory. So like most games that I play, there's probably going to be like 5 to 10 moves of theory on each side. But there's the majority of players aren't yet at the level they care about that, or who knows, maybe they're never going to want to care about that. And so I think the challenge is to try to deliver value at different points. So I've gone back based on some feedback I've gotten. I'm trying to rethink it to provide value for people who are less experienced. And, that's often things like, well, you played knight to g5. There's a black pawn on h6, which can take your knight. This is how pawns capture. You don't want to do that. Maybe slightly higher than that level, but, something that is kind of more basic.
Yeah.
I mean, fundamentally, I think the holy grail is to try to explain the why of engine move choice. And that is an incredibly difficult problem.
It's hard enough to
Interested
do
in
it for a
2 minutes on the
grandmaster.
history of computer chess engines? I'll give it to you anyway.
Yeah, I want to hear
It's
it.
really quite fascinating. So back in the 60s and 70s, I mean, people have been working on chess engines since at least the early 60s. Up until the mid 70s, they played not that much under beginner level. Then they started getting better as computers got better, and they just used Minimax algorithm with some tree pruning. And you got to the point where basically with a relatively simple terminal evaluation function, which would decide whether the position was better for white or black at the end of each variation, IBM built some really, really fancy hardware, and Deep Blue beat Kasparov in 1997. So essentially, you had an incredibly powerful machine, not consumer grade hardware by any means, that could play marginally better than the world champion in 1997 by
So no,
essentially.
no strategy beyond the next move.
The strategy is in the terminal position evaluator. So when it gets to the end of a variation, it decides who stands better. And it would obviously you just count the material, but that will still, regardless of how deep your search is, that will still not have a chance of even drawing a game against Kasparov. But you have to add things like piece square tables, so you give a bonus for pieces being on good squares, mobility, king safety. So it does some simple evaluations and says, yeah, this looks better for white, this looks better for black. But nothing really clever.
Yeah.
So another roll about 10 years, 15 years forward, there's not really any great advances in how engines work, except more efficient search, but just incremental. And hardware gets better. So you get to like, say, 2010, where now your laptop can beat the world champion. Probably 2015, maybe a good iPhone can beat the world champion. And then the DeepMind project and AlphaZero emerged from DeepMind and Google. And they applied neural networks and taught the engine via reinforcement learning with self-play. That became, I think it played a few billion games against itself and had become the best in the world within a couple of days, even better than the other engines. And the difference was it didn't do as deep search, but it used a neural network to evaluate terminal positions. And the neural network evaluation is incredibly strong. So now Stockfish, which is the leading open source engine, has incorporated neural network technology and is actually better, is still the best engine. But there's also something called Leela Chess Zero, which is based on the Google stuff inspired by that, which they're both open source. And they're both incredibly good, and they're both kind of jigging it up. But it was really fascinating how neural networks change things, where for the first time we didn't understand what the evaluation function was. Like, for example, any reasonable chess player could tell you with the Stockfish evaluation function, say before the neural network explosion, yeah, well, I mean, this is just basic stuff. I understand all of this.
It knew why
whereas
it was making the decisions it was.
what the Leela Chess Zero neural network evaluation is. I haven't verified this myself, but I have it on good authority that with zero look ahead, Leela Chess Zero plays at international master level, which is just stunning because its positional instincts are so good that it can just look at a position, look at every position that would result from every single legal move, and just say, this one smells best. And it is incredibly strong even doing that.
But it has no idea why.
It has no idea why. And it's actually been quite fascinating that it started to revolutionize top level chess. There's a really fascinating, for anyone listening to this who's seriously interested in chess, there's a wonderful book by an English grandmaster called Matthew Sadler called The Silicon Road to Chess Improvement. And he's a very strong grandmaster, and he's been interested in engines for years. And he talks about some of his own personal training regimes. If he, for example, wants to learn a new opening variation, The typical way that you would have done it is look at all the games that human grandmasters have played from that position.
Because you're playing
He
against
doesn't do
them,
that.
so
He
you're
sets
learning
up
how to
two
beat
different
them.
engines to play 100 game pairs with alternating colors. And then he has a look at the games and figures out what the plans they came up with were.
Yeah.
So
he's building a model based on the grandmasters that he's playing against.
No, he's building a model based on engines. He no longer looks at human games predominantly. He looks at engine games. So he creates engine games from any position with engines configured differently in different engines so that he gets different games. And then looks at
I guess this is the interesting evolution is that the grandmasters used to play against other grandmasters and have to like train their models around the humans they were playing against. But now the humans are training their mental models against the computer models.
Exactly. And they do it not by playing the computer, because that's pointless even for a strong grandmaster. They do it often by having engines evaluate positions and deeply looking at the lines that the engines are suggesting, or creating engine games between engines where they look at the output. And it has changed the style of top level chess. There is now, in the last probably 5 years, a style of super grandmaster chess that's never existed before among people, and it is substantially influenced by the stylistic findings of engines. But the problem is that people have to do the work of figuring that out. So even a grandmaster has to sit down for half an hour and think, what the hell does this move do?
Right. Wow. It's fascinating. Yeah, it's what an expansive space that is. That it just blows my mind every time I think about it. All the variations that exist in chess, and it's I prefer the finite world of programming and programming languages, where it's like not so many variations.
Hey, yeah, you say that, but I keep finding these things where it's like, oh, I thought it was like that, but actually it's no, there are variations.
I guess we kind of do what smells good in programming. I like that you use that terminology, Rod, for describing how the engines or the AIs determine what's nice. It's like, oh, this smells good.
That's a really good way of putting it. Yeah.
Semicolons, they don't smell good.
Certainly, I felt, when I said I didn't play chess for 30 years, one of the reasons for that was that programming scratched the same itch for me, and I could get paid for that. So chess is a very beautiful game, and I'm glad that I've gotten back into it. And I'm glad that I'm gradually improving again. But I think a lot of the beauty is similar to the beauty in programming, and you do get it. Actually, there's a former world championship contender, ex-Soviet grandmaster called Viktor Korchnoi, used to say that you should regularly learn new openings, because when you learn a new opening, you learn something else about chess. And it's a bit like learning a new programming language. There are these things where there's this whole set of ideas that you've never encountered before. And so, okay, so in this position, black can launch an attack with his A pawn and B pawn, and the bishop comes to C5, or, you can learn these whole concepts that kind of feel like they're expanding at least your chess brain in the same way as like learning Scala.
Do you suppose we'll ever get a machine learning system that can invent new games?
Yeah, I certainly, I would definitely imagine we could. Yeah, I mean, ideally.
Well,
yeah.
Exactly. How does it know what
it would have to filter it? They smell good.
They smell good.
Yeah, I totally think you could. I mean, what I would hope for first, though, is a way of explaining the choices made by a system like a neural network. Yes, not only would that be really cool for chess, but I actually wonder if civilization will survive unless it's possible for other things. Like, I mean, as these determinations of what smells good from a neural network affects more and more of our lives, it's kind of pretty important that we know why that decision was made.
Yeah.
But I thought that was like a big part of it, is that we're creating a scientific model, but a human isn't creating it. A machine is doing it just by looking at a ton of data, and not, it doesn't have a reason why it says, oh, I should add this little bump in my algorithm. It just says it fits the data.
But it doesn't, there is really no way of knowing why. Like, I mean, if you look at some of these massively over-parameterized models now that they're using, I mean, there can be billions of neurons in the model. And, it's just totally opaque.
Yeah. Yeah. So the solution is just more data.
Apparently.
Always.
Well, I mean, the solution, I guess, if we can't explain it, the solution is ensuring that it gets the right training data, so you don't get things like, for example, that Microsoft chatbot that bad people
just went
thought to be racist.
Went full Hitler within a few minutes. A friend and I were playing with some machine learning. It would generate stories. And one of the things that we discovered was that it was really tuned to be positive. I think they were saying, well, we don't want that thing to happen. And if you wanted it to go dark, you really had to push it. You had to go, and then his puppy died. And then he, and only then you'd really have to, because otherwise it would go, and then he got a new puppy and he was really happy. It was just really hard to get it to.
So the data that was trained on was much more positively oriented.
They had dialed some knobs
country music,
because
what's it, tragedy. Hadn't been trained on tragedy.
No.
Yeah. So this reminds me of DALL-E, the image generator. Which was fascinating to see the images that it generated. But for me, the most amazing thing of DALL-E was not the images that it generated. It was the combinations of things that humans came up with. It was like the human creativity, the way that humans used the tool was actually much more amazing to me than the actual tool itself. So it's like the human creativity element to this is always the thing that makes it, that gives you the human connection of it, the human wonder, that when it's just purely the AI, you're just like, no wonder there. So, yeah.
It is funny that with, I remember when I was at uni, our professor the head of department was enthusiastic about AI. And this was during the AI winter. So he used to cynically define AI as the set of things that don't work, because he said as soon as anything is solved, they say, that's not really AI. Whereas roll the clock forward, a lot of the algorithms are the same. Like, I mean, neural networks have been around since the late 50s. And there haven't really been that many radical advances. I mean, dropout layers were clever, but there hasn't. I mean, if you look at the way a neural network works today and you show it to a computer scientist in the late 50s, they would totally understand it and say, that's how it should work. And yet the difference is that you've got faster machines and you've got many, many, many more data points. And so this stuff that we knew how to do suddenly starts working and having real world consequences.
Yeah. Fascinating. Well, I don't know. Anything else? My mind is expanded.
Yes.
Thank you so much, Rod. It's good to see you, and fun to learn from you as always. So appreciate your time, and that was fun.
Great to see you guys again. I really hope that I get out to your mountains.
Yep. Yeah, we'll get you out to Crestview next winter. So that'd be great. All right. Well, thanks, Rod. Have a good one.